Welcome back to the channel. It is bright and early here, and today we're going to be looking at marble diagrams. Before we get too far into the tutorial, I wanted to note that this is not going to be a tutorial about how to use RxJS or observables. It's simply to help you understand those marble diagrams that might look like little kids' drawings in art class to you right now, but actually they can be super helpful to quickly understanding the different RxJS operators. This video is going to be perfect for someone who has a base understanding of how observables work and how RxJS works, but still have not quite figured out how to effectively use these marble diagrams that you see everywhere. Let's go ahead and jump right in. We're going to look at rxviz.com, and this is an online playground that allows you to visualize observables and play around with the different operators. So if we just use the example here and visualize a basic interval where we're taking the first four values of that interval, you'll see on the right this is the timeline of this observable. And so this is a great place to start because we can break these into different pieces. So starting off, we have this horizontal arrow, which represents the passage of time. And now the important thing to know with these observables and with these operators is that the passage of time is relative. We don't, label these as this happened at 1 second, 2 seconds, 3 seconds. We say that the 0 value was emitted before the 1 value, which was emitted before the 2 value. And you'll see why this, it would be hard to attach actual time codes to this. So just know that time is relative. The second thing that you have to know with these marble diagrams, and this right here is not a marble diagram, but it is going to give us the concepts that we need, is the concept of this vertical line here at the end. You're going to see this vertical line, and what this represents to you is basically the end or the completion of the observable. Now, not all observables actually complete. That kind of gets into a topic of hot versus cold observables, but for now we're just going to stick with the ones that do complete, and on completion they're going to, in the marble diagram, show up as that vertical line. Now, you also might see something different. So if we were to just pop in here and use the tap operator, which we don't really need to know how that works, but basically it's just going to grab the value that we're using here, and it's going to do something with that value without affecting the output of the observable. So we're just going to throw an error. And what happens when we visualize this is that at the first emission we're going to see an X. So anytime you see this X in a marble diagram, that indicates that the observable threw an error. And then finally, we're going to look at the actual values. So let's go back to our original one here. And you'll see that each of these circles represents a single emission of a value. Now, with marble diagrams, you're going to see more than one of these horizontal arrows with the values and the vertical lines and the X's, but this is the basis that you need to understand those different symbols. Let's take a look at some of the documentation at RxJS. So I've got this pulled up, and I'm under the operators section where you can scroll down and see all of the different operators that you can use with RxJS. So we were using the timer operator, and when you click on that, you'll see all the documentation, including a marble diagram. And why we want to use these marble diagrams is because if you come up and look at the actual description, some people might be able to understand this at first glance, but I certainly can't, and I'm guessing that others like myself cannot either. So looking at the marble diagrams is going to be a much more straightforward description of each operator. So what we're looking at here is a creation operator, and that is different from a pipeable operator for a couple different reasons. But in terms of marble diagrams, what you're going to see with the creation operators is there's just going to be one single horizontal arrow as we saw in the visualization playground. So a creation operator, it doesn't need any source observable to operate on because it is the source. And so if we go to a pipeable operator, we'll just go to a simple one called map. Most people would probably be familiar with this one. You'll see that now we have two arrows, and in between those arrows is the operator itself. So that's the difference between a creation and a pipeable operator when it comes to the diagram. We'll get into interpreting these diagrams in just a second, but let's pop over to RxMarbles, which is my favorite place to look at these different marble diagrams. And the reason being is because you can drag them around and actually see a real-time output of how moving the different output values will affect the end result. Now, I want to define a few things in terms of terminology around this, because without it, we're going to be pretty lost. So what I have up here is the switchMap operator, and this one, I picked this one because it's going to demonstrate some of the terminology that we're thinking about. So the first thing that we have to understand is that the lines that we see, or the horizontal arrows we see above the operator, are what we call input observables. So these are the observables that are going to be emitting values, and those values are going to be acted upon in some way according to the operator and its internal logic. And so these input observables, we can just call them that for now, but they can actually come in a couple different flavors. So what you're looking at here with the switch map, we would actually call this top line the outer observable, and the second line would be the inner observable. And to my understanding, this is just simply how we write the code. So as you can see in the operator, you actually have this observable 1, which is the top one, on kind of the outside of the function, and then you have observable 2 in the inside of the function. So with these operators like switchMap or something like exhaustMap, these are going to have the concept of inner and outer observables, but we can just call them the input observables in the case where it doesn't matter. So let's go to one, let's see if we can find one that does not have this concept. So with the combineLatest operator, it doesn't really matter which order you put these top two observables in. You can flip them, and the output observable, which is always going to be the one at the bottom, is always going to emit the same values. So again, I could totally flip these top two around. It's going to give me the same value. But if we went back to the switch map, if we were to flip these top two lines, we're going to get a completely different result in the output observable at the bottom. So just be very, very clear as we're going through this. Keep that concept in your head. So within a marble diagram, at least most of them, you're going to see more than one input observables. And we can just generally call them input observables, but in some cases, you'll see that the top one is the outer and the second one is going to be the inner. So keep that terminology in mind. Now that we got our terminology straight, let's jump in and actually interpret a few of these marble diagrams. As you'll see, it's more of an art than a science, and practice is the best way to start learning how to speak the language of marble diagrams. So we'll start with a super easy one. That'll be map. It's something that we're all familiar with if we've used JavaScript arrays, and therefore we're going to start with it. So with the map operator, the way that you're thinking about these marble diagrams, again, is the concept of your inputs and your outputs. It's literally like a pure function where you're always going to get the same outputs given certain inputs. And so in this case, in this RxMarbles diagram, what you're going to see is that the input values are 1, 2, and 3. And what happens is the value of 1 is going to be emitted at some point in time, and then it's going to be transformed using the logic of the map operator. So in this case, it's going to be multiplied by 10. So 1 times 10 is 10, and you'll see a output value in the output observable of 10 exactly when the first input observable emitted. You see the same logic going forward, and we can even go into the playground here and see this in action. So the interval operator is a creation operator, and it's just going to emit the value, a value every second based on that 1,000 that we put in there, and it's going to start at a value of 0. So it's basically going to count 0, 1, 2, 3, all the way to infinity if you let it. So what we're doing here is we're saying we just want to take, let's just take the first 2 values, and what we want to do with those values is map them. So we need to import that real quick, and we're just going to take the value, that's just an arbitrary variable name, and I want to say I want the value times 10. Since the interval is going to give us a value of 0 first and then 1 second, and we're only taking 2 values, we would expect that the output observable here to equal 0 and then 10, or 1 times 10. So let's try it out. We're visualizing it, we get 0 and then 10, and then our observable completes. So that is the map operator. Let's do one quick easy one again and just keep getting warmed up, and then we'll jump into some harder ones. So we'll look at the filter operator, which is basically going to take some condition defined within that operator and apply it, and if the condition is met, then it's going to emit an output value in the output observable. So you can see pretty easily what this is doing based on the marble diagram. The logic says I want anything that is greater than 10. So the input observable emits first a value of 2. It goes through the filter operator, does not pass the condition, and therefore no emission in the output. Then it emits a value of 30, which goes through the filter. That is in fact greater than 10, so we get an output value in the output observable. Likewise with 22, that's greater than 10, we get another output. 5 is not, so no output. 60, and so on and so forth. So we can see that visualized again in the RxViz. So we can even just continue on with our previous example. We'll go ahead and take 5 this time, so I'll play that out for you. And then we can say filter, we'll add that in. And this time I only want values that are going to be less than, we'll say 40. So it's basically going to cut off that last value. And so we can visualize that, and it's going to cut off that last value, and it completes at the end. So that's just the basics of marble diagrams. Now obviously these are pretty easy, but the concepts are going to stay the same as we go into the harder ones. Hey, just before we keep going, if you found any value in this video, if you've learned anything so far, give it a like and go ahead and subscribe to the channel so that you can get more videos just like this. Alright, we'll get back to the tutorial now. I think the next operator that we're going to look at is the combineLatest operator. I've used this quite a bit, and I think it's going to be a gradual increase in difficulty for us. So let's go to RX Marbles, find the combineLatest operator, and start taking a look at what this is doing. So I'm going to try to help you just think through how this is working, and then we can actually see it in code. Let's take it one by one and see how this is working. So just intuitively looking at this, remember we have our 2 input observables, and in this case the concept of outer observable versus inner does not matter. So we have 2 input observables, they're treated equally, and as you can see they're emitting values at different time points. So the first thing we're going to notice is that the input observable 1 emits a value of 1. But if we come down to the output observable, we don't see anything. Nothing has been emitted. So that's kind of weird. Like, why is that happening here? Well, we go to the next value of 2, and this time it would emit a value. And even when the input observable number 2 emits its first value of A, we still get an output. So what this is kind of telling us, and you can kind of learn this from the documentation if you were reading through it, but basically this combineLatest operator is not going to emit an output value until there's at least one emitted value from both of the input observables. So that's why after this first emission of 1, we don't see an output, but after the second observable, or the input observable number 2 emits a value of A, we have a value from both, and we can combine these values into an output. And so hence the name combineLatest. What this is basically doing is it's taking the input observables and it's grabbing the latest 2 values of each every time either of them emits any value. So let's go to an example way down the timeline. So let's go to this one right here. So the 4. So the input observable number 1 emits a value of 4. This is a new value, and while input observable number 2 has not emitted a value in quite some time, it's still going to grab the latest value, which is D, and combine it with the latest value of 4 to get 4D down at the bottom. So you can kind of see how this is working, and let's take this example to another operator that's going to look a little bit similar. Taking a look at the zip operator, you'll notice that the output looks very, very similar to the combineLatest. So how are we meant to distinguish between the two? Well, again, this is more of an art than a science, so let's go ahead and look at this and try to figure it out deductively. So the first thing we'll notice is that when the first value emits, we don't get an output. So this is exactly like the combineLatest operator. So far it's exactly like combineLatest, and then we get to the first emission of the input observable number 2, and we get 1A. So far, like, this is exactly the same as combineLatest. But in many cases, we have to read a couple different values before we can figure out exactly what's happening. And of course, we can look at the documentation and look at tutorials to figure this out too. We're not, bound to just looking at these marble diagrams. But what I'm trying to prove to you in this video is that with the marble diagrams alone, you can almost always figure out what these operators are doing. So we'll look at zip here, and let's take a look at the value of 4. We looked at this in the combineLatest operator, and you can see if we go back, the 2 input observables are emitting the same exact values in both of these examples. So it's a good comparison. So we go to zip, and you'll see that the value of 4 emits a value of 4D. So in our minds, we haven't figured this out yet, so we'll just say like, oh, it's grabbing the latest 2 values just like combineLatest. So what's the difference? Well, we find the difference when we go to this last output value of 5. And you'll notice that in the zip operator, we don't have an output value in the output observable here. Well, if we go to combineLatest, we do. Because in combineLatest, remember, it emits a value every single time either of the input observables emit a value. And so the input observable 1 emits a value of 5. We combine it with the latest values 5 and D to get 5D. But with the zip operator, we don't get this output. So that tells us that something is different, as we would suspect, and now we kind of have to figure out that difference. And so if you look at this long enough, what you'll realize is that the zip operator is basically mapping the 2 input observables and like matching up the values. So again, I would say that the rule here is that both of these input observables have to emit at least one value to get an output. But then if you look, if we were to kind of, and this is why I like Rx marbles a lot, is you can kind of play around with it to make this make a little bit more sense. So let's go ahead and match these up. if we were to drag all of these to match up, you'll see that we're getting these two input observables are basically just combining together on every time both of them have emitted a new value. So we pair the 1 with the A, the 2 with the B, the 3 with the C, or in other words, we're going to take the index of each input observable emission, and we're going to map that up with the same index of the other one. So again, the first value emitted by input observable 1 is going to be 1. The second value is 2. And my light is flickering. We may have to turn this off for the tutorial, and I may be getting a new light. Okay, we have no light, but we're going to finish the tutorial anyways, and I will worry about that one later. So anyways, as I was saying, we have these indexes. So the first value of the first observable is 1, the second value is 2, the third 3, the fourth 4. And if we go down and do the same logic with the second one, the first value is A, the second is B, third is C, and so on. So what the zip operator does is it matches those indexes up. So it's always going to match the third index of each input to the to each other. So the third index would be 1, 2, 3, or if we're talking in programming terms, 4. And you see that they're matched up. So we could even do this where we're taking this first input observable and we put all the values to emit immediately at the beginning. But we're going to get the same output here because we're still mapping up the values. So the 1 goes to the A, the 2 goes to the B, 3 goes to C, 4 goes to D, and then 5 does not have an index to match to because the second input observable has not emitted a fifth value. So you can kind of see how we figured this out with the combineLatest versus zip. And if we went back to combineLatest, you'll see that if we were to drag these just as we did with the previous, it's not going to work the same. So you're going to get a different result with this output. Hopefully by now you're kind of getting the hang of this. And if you totally get it, if this makes sense to you, this could be the end of the video for you. But we're going to go into a few more examples for those who want those few more examples and to kind of just understand how we might think about some more complicated marble diagrams. So the next one we're going to do is switchMap. And the reason we're going to do that one is because switchMap is a little bit tough to understand, and it brings in the concept of this outer versus inner observable. So previously with the zip and combineLatest, these top two observables, it didn't really matter what order they came in. I mean, you could argue that in zip it kind of does, but with switchMap, the order of these two matters a ton, and you're going to get a completely different answer if you were to flip them. And that's why we call this first one the outer observable, or aka input observable number 1, as we've talked about it before. And the second one will be the inner observable. So first off, the outer observable emits a value of A, and the inner observable emits a value of 1. So we get A1. Now this is pretty similar to what we've seen before with combineLatest and zip. So what's the difference? Well, let's keep reading. The second output value is A2, which pretty similar to combineLatest. We've eliminated, it's definitely not zip because the first outer observable has only emitted one value, but we're still tracking along to the same logic of the combineLatest operator. We get to the value of A3 and we're getting the same logic. So what's the difference? Well, the difference comes once we read to the fourth output value. And you can see that after 3 values, the inner observable or inner observable number 2 is done. It's done emitting values. So with that logic, you would assume that the output observable is not going to emit any more values because with, an example like combineLatest, it would just stop. But with switchMap, what is actually happening here is that this second or inner observable is actually being used more than one time, as we can see. So let's look at the second value that's emitted by outer observable, and that is B. So we see that when B is emitted, we match that up to the first value of the inner observable. So what's really happening here? We can kind of infer that this inner observable is being used more than once, and you can see that each time, at least so far, each time the outer observable emits a new value, we start over. We kind of like resubscribe to this inner observable, and we start from the beginning. So we see that we emit the value of B, we get that matched up with B1, and then you can see we get another output. This is actually B2, but then something weird happens. We get a value of C1, but where is that last value of B3? Well, that is the magic of the switchMap operator, and that is exactly what it's trying to do. What the switchMap operator is trying to do is basically cancel the inner observable on each new outer observable emission. So in other words, we emit the value of B, we get a similar output as we got with this first sequence, so we get B1, B2, but then it's cut off. And the reason it's cut off is because the outer observable has emitted one new value. So the outer observable emits a value of C, and what this says to the logic of this whole operation is it says, okay, we've emitted a new value of C, now cancel that inner observable that was happening before with the B, and let's start a new one. So you can see that it starts new at C1, and then it plays out just like this first sequence of A1, A2, A3 worked out. And then also you can notice that if we change the interval of time that we're using for this inner observable, we basically scrunch the output values together. All that's going to do is, basically make the interval between the output observable closer, but it doesn't actually change the logic in the outputted values. So what we can conclude from this is that the switchMap operator has a canceling effect. And it basically says anytime an outer observable emits a new value, we want to cancel the previous inner observable subscription. We want to resubscribe and start over from the beginning. And then we want to output the values at the same interval of time according to that input observable. So in other words, the output observable determines what subscription we're using, and then the inner observable determines the timing of it. So if we make this a much bigger time, you can see the output values are spaced out more. And to make this a little bit more real for you, I wrote it out in code. And you can just take a look at this and see that I've labeled the functions similar to how we've been describing this. So you've got the outer observable, which is basically going to emit values. Let's just comment this out real quick, and I can show you exactly how this is working. So the outer observable is going to emit these following values if we visualize this. So A, B, and then C, very similar to what we looked at here with the marble diagram. And then if we were to show what the inner observable is doing, we can uncomment this real quick. So let's play out the inner observable. It immediately emits a value of 1, then 2, then 3. And then if we combine these into our switchMap operator, you'll see that it works exactly like we saw in the marbles diagram. So I'll leave this code in the description and you can kind of play around with it on your own. But this is an illustration of how we might interpret a little bit more complicated operator like switchMap. Now, This is where you could also, use a combination of the marbles diagram and also maybe look up some tutorials online like this one, or, just read the documentation and get familiar with that. As you can see, interpreting marble diagrams is first about understanding like how to read them in the first place. What are all these different symbols? Second is understanding the concept of this like input observable and how some of them have the concept of outer versus inner observables, and how do we distinguish between that. And then finally, just using your intuition and your deductive reasoning, going through the outputs of these marble diagrams and trying to almost put it together like a logic puzzle. And when you can do that, when you realize that this is not exactly a straightforward science where it's like step 1, step 2, step 3, once you realize that, you can kind of treat these as more of like a puzzle that you have to solve. And hopefully that perspective helps you out, helps you understand these marble diagrams a little more, and furthermore helps you shift your focus away from typing in like how to use each operator on Google and focusing in on the marble diagrams and letting those be your teacher. And that's it. If you liked this video, give it a thumbs up. If you want more examples like this, be sure to leave that in the comments and I may create another video. Until then, I'll see you next time.